going over the homework from P2, and we're looking at number 49 first. And I need to grab the book to see what it was asking us to do. I think it gave us an equation and asked for intercepts, but so I don't make up the question. 49. Okay. It says x-intercept is 2, 0, y-intercept is 0, 3. Write your equation, put it in general form. So the first thing that I did, I know the y-intercept or the b value is 3. I found the slope by putting in one of the ordered pairs. I put in 2, 0 to find out the slope. So I know my equation is going to be y is negative 3 halves x plus 3. But they put it in general form. So they asked for general form. So what you want to do in order to get it into general form is to multiply everything here by 2. So that'll be 2y equals negative 3x plus 6. Because you have to remember to multiply that 3 by 2 as well. And then they pulled everything to one side. Okay, any questions? And if you use 48 up above, they had the x over a plus y over b equals 1. You don't have to memorize. That's just a pretty cool thing that all lines will work out that way if you know the x and y intercepts. So if you did it this way, x over 2, a was the x-intercept, plus y over 3 equals 1. I kind of forgot that that even works for a line. But then they solved that by multiplying by 6 to get rid of the fractions, and we'll get the same answer. So you may have just done it this way instead of going through what I did. Either way is fine.
I think seeing like what they were trying to tell me how to do it, I think seeing that confused me.
Yeah, it was just the equation that works for all lines if you know the intercepts. I don't remember that. Yeah, I don't memorize that at all. As a matter of fact, I looked at that and went, oh yeah, that, you can do that. But I probably would have gone and done it the way I did it. Okay. All right, 59 is the other question. And this one asks for lines parallel and perpendicular to a given line. So the first thing you have to do is steal the slope from the given line. So I solved it, put it in y equals mx plus b, so I know the m is 2. So if I want a line parallel, I know the slope's also going to be 2. But now they tell me the point it has to go through. You could use y equals mx plus b. I could have used point slope form. But they put the answer in the back in general form. So I did y equals mx plus b and then put it in general form. If you did point slope, yours is going to look like this. And then you're going to have to put it in that form. It doesn't matter, okay, which form you used. And then this one, if you put it in point slope form, it's going to look like this. And then you can solve it. Or if you use y equals mx plus b, but then you have to put it in general form to make it match up in the back. So why do we have to do that? Because if it's on a test, I don't care what form you put it in, okay? But if it's a question in the book or in the packet and you have the answer, we want to try to match up with that answer. It makes you very good at multiple choice questions. Because when you do a problem on the AP part of the multiple choice, they often manipulate the answers. So that makes us pretty good at manipulating the answers. Any questions on that one? Does anyone need me to go through how to put this in general form? Multiply everything through by 2, and then swing everything to one side. Okay, so let's go to while we're on this set, we'll do 73 and 77, and then we'll come back and do 5. So, because it was on a different page. So 73 is a presentation. They're trying in this one. Who had that one for us? Someone had that one. Taylor. He's not here. He is here. Did you do 73 for us? Okay, come bring it up. Yeah, tell us what you did. What they did on 73 is they tried to make lines into an AP-ish type question. So this is more like kind of trying to make something a little more difficult. Okay, so 73 gave you this equation, and then what did you do in part A? Good, yeah.
Well, for the first part, I plugged in 0 for A because that would give me the equation y equals 4 over b.
Mm-hmm.
And then for b, I plugged in b because then if I plugged it in for the first equation, I got x equals 4 over a. And then for c, to get a slope of 5/8, I did -5 because there's a minus sign in front of it. And then I did 8. For d, to make it perpendicular, let's see here, I changed the equation from there, and then to make it, and then I made it the reciprocal here, and then I had to make it make that positive, so I did a -1 there. And then for e, because this is similar to that one, I just divide by 2, so then I got 5 over 2 and 3.
Okay, so good. Questions on A. He knows when A is 0 and B is not equal to 0, he'll get that equation. For B, when A is not 0 but B is 0, he'll get that equation. C, you could have answers that vary as long as your slope turned out to be 5/8. So what he had to do was let it be -5 and 8. But you could do like -10 and 16, anything that would have reduced to that. Now D, I have something different, but E, we're basically gonna just divide those by 2 so that we can figure this out. I think they wanted you to keep the -5 halves for D. So I let the A be 5 and the B be 2 so that it'll be opposite and 5 over 2. If we did this, we'll have too much. You have 5 halves over 1, so I don't think that will turn out. Let's look at what the actual problem was just to make sure. I don't know if that one's gonna work. Give the values of A and B such that the line is perpendicular to y equals 2/5 x plus 3. So we want the slope to be -5 over 2. So somehow you have to let that A over B reduce so that it's -5 over 2. So you could have different answers. This is the one that I used. A is 5 and B is 2 just because it was the easiest one. So that's the only thing we'll need to change is D. Any questions on that one? So I tried to make it into like an AP type question. Okay, and 77 is the next one. This one was a little word problem. Okay, and good job on that last one.
So, like with the first two equations, I just like took what they were saying in the problem and just transferred it into an equation. And then for part B, I found the point that they intersect on the graph and just traced it. And you had to like interpret what it meant. So it was like when your new job will pay more, but once you exceed that point, your old job will pay you more. And then for part C, I just ended up plugging in 20,000 to each of the equations and solving to find which job would pay more whenever you sold that much money.
And on C, you should stick with the current job, right, was what it turned out to be. Okay, so part A, we get the equations. They told us what the S and the W were, so we could just use their variables. For B, you want to graph it. So on your calculator, you want to find some windows. So if you do a problem that's a graphing one, and this one, they didn't ask you to actually graph it, but so that we know what the window is, we're going to write that down. I use this window. You certainly could have used another window as long as you can see those intersections, but it didn't happen in Zoom Standard, for sure. So I let my X min be 0, X max be 30,000, my Y min be 0, my Y max be 4,000, and then I was able to see that intersection. So as long as you could see both lines in the intersection, your window's fine. Okay? But just jot down the window on your paper and then you'll know what that is. And she used the intersect feature on the calculator to get that. And then what they're looking for is like, which job should you take? So if you have $15,000 in sales, does it matter which job? Because either job, if you have $15,000 in sales, you're gonna earn the same amount, okay? If the sales are less than $15,000, then you wanna go with the new job. If the sales are greater than $50,000, then you wanna stay with the current job, okay? And then in part C, she figured that out for the $20,000. It would be stay with the current job because you'll make more. questions there. That's kind of like, believe it or not, they have those on like the 8th grade PSSA. That's almost like a type of question that they would have. Sometimes they'll do cell phone companies and they'll have them write the linear equations and figure out which one you should go with based on the number of minutes. So that's that type of question. Okay, good, thank you. And then we get to number 5. Why they want us to do number 5 is we're gonna see the same problem again later, but we're gonna use calculus to solve it. This one, they just wanted us to use algebra. So this is an algebra 2 question. They basically have this farm, I think it was a farmer and fencing, and the building was going to be next to the river. So they gave you a picture that looked like this in the book. They said there's 100 feet of fencing. So I know that x plus 2y is 100, because I don't want the other side that's next to the river. And then they asked you in part A, well, what's the area? Well, I know area is length times width, so it's x times y, but I can't really do anything with that until I get it in one variable. So what do I have to do? How am I going to get x or y in the other variable?
Solve for y.
Yeah. So I'm going to solve this equation. I could have solved it for x or for y. It doesn't matter. I solved it for y because we're so used to solving for y. So I got 50 minus x over 2. I plugged that back in, and now I have my area equation. And it's just a parabola, isn't it? Okay, so we want to be able to do that, because that's just using substitution, using one equation, subbing it into the other. Now I know the domain, based on the fencing, has to be from 0 to 100. It can't be 0. We don't want it to be 100, or we won't have a rectangle. So then part B asks us to graph it. So I'm graphing it because I'm finding the maximum. Now what we're going to do is we're going to learn this year how to do the same exact problem, not even graph it, find the maximum using calculus. Okay? But in order to do this one, I needed a window, and I wanted to make sure it fit. So here's the window that I used. And again, if you do a graphing problem, write down the window, or if you graph it, your window could just be found by 0 to 100, and I could write this one, I went 0 to 2,000. I went by 250s, this is 1,000. So I could write that there. Then I wouldn't have to write a separate thing that says window. I would see it. And then I found the max. So it's second trace. Everyone remember how to find maximum? It's under second trace somewhere. I found the maximum on my calculator. It was at 50, 1,250. So what I know is that x is 50, the area is 1,250. So my dimensions are 50 meters by, and I went back in to find out what the y would be. So I know it's 25. Include units, okay? So include units, the meters. The maximum area would be 1,250 square meters. And then part C says, well, do the same thing, but complete the square. So this one, probably some pens moving on this one because we probably forget a little bit about completing the square. So what I did in order to complete the squares, I took that quadratic, and if you remember the rules for completing the square, you can't do it until the coefficient in front of the x squared is a 1. So whatever's in front of x squared, I had to factor out. So if I factor out a -1/2, I'm taking 50 and also dividing it by -1/2. So I can figure out that's -100. Now when I do factoring, especially with fractions, mentally always distribute because you can catch all your errors. Now to complete the square, do you remember the little formula? How did I get that number? Complete the square?
B over 2 squared.
You got it. B over 2 squared. So B is the number in front of x. So 50 over 2, 25 squared. Or actually 100, sorry. 100 divided by 2 squared. So that's how I got this number. But why did I add 1250? Where'd that come from? Where'd that come from?
You're supposed to add 2,500 times whatever's outside the parentheses to the other side, which
Yes.
would be -1250, so we put it back from the last maximum.
Exactly. When you complete the square, you randomly are adding something. You can't just add something unless you add it to the other side. So when I added, I really didn't add 2,500. I added -1/2 times 2,500. So I need to add negative a half times 2,500 to the other side, but there's really not another side, it's A. So instead of subtracting 1250 from the other side, I just added it to this side. Because if I multiply this all out, what should I get back to? That step. So these two numbers would cancel out. This is algebraically equivalent. And then, when you complete the square, we force this to be a perfect square, trinomial. So it's negative a half times x minus 50, quantity squared plus 1250. Now, why we learn this when we do quadratics, it's easy to get the vertex. It's always opposite of what's in the quantity, comma, that number. So your max is real easy to get. I know it's a max because it opens down because the leading coefficient's negative. So I find out that it's 50 for x, 50 meters, 1,250 meters squared for area, and then I can find the y. Any questions on that one? That one tends to, even though that's not a super difficult problem with the exception of part C, completing the square is hard to remember, but parts A and B are pretty doable. So you want to make sure that you can do that. I know we see words and we go, oof, no, this is going to be a harder problem. And it's not. It's really an Algebra 2 level problem, but why they want us to see it now, we're reviewing our algebra, and they're going to throw the same problem at us. It becomes a classic calculus problem, but we won't see that until chapter 3. Okay? Any questions? Is there anything else on the homework? Okay, test on Thursday on the summer packet. It will be no calculator, because you didn't need a calculator for any of those. And it'll be just the period, so you'll just have 40 minutes, so you have to pace yourself. Is there any question, anything else from the summer packet that you have a question on? Nope, I'm testing you on it. So if you did it, you know it. It's very apparent. If you don't do well on the test, I know you didn't do the summer packet and you don't have the prereqs.
On like this section 4 part of the summer packet, whenever I was doing it, I had to look back to the answer in order to know what I was working towards. How would you know what you're working towards if you don't know the answer?
Well, you could leave it in any form. That's a great question. Set 4, how do you know like what to leave the answer in? You can't have any negative exponents in your answer, and you can't have a complex fraction. So if you have factored it out and you no longer have any negative exponents and you just have a fraction, then it's good. Okay? Any other questions about that?
About the test, like, do you know how many questions there are?
I give you a lot of space to write. I think there may be 10, but there will be a little bit on each topic. You know, I'll pick a problem from each kind of set. The graphing will be real basic graphing, just a basic graph. I'm not going to have you do anything with LNs where you have to translate them or flip them upside down or anything. If it's it's going to be the most basic graph. Set 4, I'm going to try to give you the easiest problem. I'm not going to try to make it super difficult, but just there are certain things that you have to know so that I can get you to the next level. And if you don't know those things, we need to know that. So, any other questions about the test? Okay, let's talk about P3. This is actually your part of your homework, so we're going to start it right now. In your packet, pages 44 to 48. Oh, and tomorrow we're going to do that activity, reading that online algebra errors book, the one where he's trying to prove 1 + 1 = 2 or something, and like does a pretty good job making it look like that happens, but there's an error. We're going to talk about that, so make sure you have pages 50 and 51 in your packet. That went along with it. So I have the link to that online book on the announcement page, but from pages 50 and 51, the very last question is the most important. It's kind of reflecting on what you did and what errors you make, because if you identify them, you're probably not going to make those errors, okay? All right, so section P3 talks about graphs and their functions. So I just want to do a couple things. As you go through, you're going to just fill this out as you're going through section P. So you're going to, review some definitions, like what is a function, what is domain, what is range. You're going to get to some words that might not seem real familiar. implicit and explicit. You're going to see that a couple times. All it means, if it's in explicit form, is they solved it for y equals. If it's in implicit form, they did not. You have to kind of do the work. So explicit form is already in y equals. When we do differentiation this year, we'll do implicit differentiation, so they want us to know what that word is. Will I ever quiz you on what that word means? No. But it's just that's what those forms look like. So what I would like to do is the harder one of the problems, which is example 1c. Do you remember this guy from last year? F of x plus delta x minus f of x all over delta x? Do you remember what that's called? DQ and not ice cream. Do you remember what it's called?
Is that like something with limits?
We're going to use it for limits, so when we start chapter 1, where I'll actually start, we'll go, chapter 1 is another review chapter from last year, but I'll teach you it. This intro stuff is kind of tough, because I'm not really teaching you it, I'm just trying to have you review it. But yeah, when we do limits, it's going to lead into it. It's going to help us get to what a derivative means. But it's called what's subtraction mean? It's a difference and it's a fraction, so the Q is a quotient. So it's a difference quotient. This is called the difference quotient. And what they want you to do in example 1, when you go through and do the examples, they'll say f of 2. Well, that's easy. You put in 2 everywhere you see an x. This is a little more difficult because it's saying go to your function and replace the x. So I'm going to rewrite x squared plus 7, but what am I going to put in place of the x? X plus delta x. So that's f of x plus delta x. Then it says now subtract f of x. So I'm going to subtract f of x and I'm going to write it wrong and you tell me why it's wrong. Yeah, needs to be in parentheses. And then all over delta x. That's called the difference quotient. We're going to need it because it leads us right into what a derivative is. So we'll be doing some difference quotients. So what we have to do is simplify this thing. So I'm going to FOIL the first quantity. And then I'm going to distribute the minus sign. And anytime, if you do a difference quotient, if you do it correctly, what is going to cancel out all the time is the last stuff. Okay? If you do it correctly, you should be able to cross out that and that. And then with what's remaining in the numerator, what can we factor out? Good. Delta x. Which the delta x is canceled. And last year you got something that looked like 2x plus delta x. Sometimes they use an h instead of delta x. Either way, you're finally going to know what in the world that was. Okay? So we will learn, why are you doing that? What does it give you? It's basically going to give you a slope. But we'll talk more about that when we get to chapter 2. Any questions on difference quotient? Okay, so there's that one. And then it's going to talk about domain and range. So we're going to fill in a few things right now, and then the homework's to go back and fill it in, and there's a few problems from P3. And we need some presenters, so before I forget for tomorrow, any takers on number 9? We need 9, 71, and 81 for tomorrow. Remember, the binders are in the back with workout solutions, or you can come in if you have some questions. Okay, so Grace, number 9, and then just try to match it up with the answer in the back. Okay, Catherine, number, which one are we on? 71, I believe. Is that the one I have up there? Yes, 71. And one more, 81. 81. Should I pick randomly from those that haven't done one yet? All right. 81, Evan.
Oh,
Try
great.
that one for us. You're so lucky.
Yeah.
Yeah. That's what I call it, right? Luck. All right, domain and range, we're seeing those words again, implicit and explicit. When you have an explicit domain, they give it to you. Okay, so explicit equations, they solved it for us. Explicit domain, they give it to us. Implicit equations, we gotta do the work ourselves. Implicit domain, we gotta do the work ourselves. Okay, so that's kind of the difference. Explicit is explicitly stated there for you. So let's try some domain and range, because these tend to make us think a little bit. Domain for the first one. What do you think? What values could you put in for x? And this one goes to, so you know where it is. It's example 2. This one is part A. Okay, this is example 2, part A. And this one is example 3, which is below. Okay, we'll do those two. So we'll fill in the example 2. You'll have to do example 2B. We'll do example 3. So domain and range. Good. Now this year it's not going to matter if you do this or this. You want to be familiar with interval notation in case they give you directions that have interval notation. But I don't care which way you put your answer. So the domain has to be, because remember anything under a square root has to be greater than or equal to 0. What is the range? Think about what that graph looks like. So anytime you have a square root graph, this one's moved 1 to the right, the range has to be?
0 to infinity.
Yeah. And it can be equal to 0. You could write it either of those ways. It does not matter. Okay, so it's going to ask you some questions with domain and range. And then it's going to give you a piecewise function in example 3. So this is example 3 from the book. So write down what that function is. And there's a grid there for us to graph it. Fun, piecewise functions. We tend to make piecewise functions a lot harder, really, than what they need to be. You just want to pretend like this is 2 different problems, okay? So for the first problem, 1 minus x, we could all graph that. The y-intercept is 1. Now I'm not going to put actual points on there yet. I'm just going to put where it would be. And my slope is -1. So I know the line 1 minus x would look like that. But with a piecewise function, they only want me to graph the parts where x is less than 1. So I don't want 1, 0. I want an open circle, but I want everything that's less than 1. So I'll take that part of the line. Remember doing those? And then the square root of x minus 1. Square root of x minus 1, I know, starts at 1, 0, and now I'm allowed to include it. Do all piecewise functions meet? No, this one does. They meet at 1, 0, and then I know 2, 1 would be a point on that graph, and I know the square root looks like that. What is the domain now that we have that function graphed?
Negative, positive, infinity.
Yeah, you could write it that way. You could write all real numbers. And the range, the y's are,
0 to positive.
yeah, 0 to infinity, or you could write y is greater than or equal to 0. It doesn't matter. Okay, other things that are going to be reviewed in the section, P3, they're going to go over 1-to-1 and then graphs of basic functions. So these are functions. If you flip to the top of the next page where it says draw all the 8 basic functions or parent functions, we can graph y equals x. They should have arrows on the ends, but it goes through 0, 0, 1, 1, negative 1, 1. So you can graph that line pretty quickly. The second one is the space for y equals x squared. So they want us to remember what that looks like pretty easily and quickly without a calculator. The next one is x cubed. The fourth one is the square root of x. Then you have the absolute value of x. One over x. And then a basic sine, you only really have to sketch one period, but a basic sine, so you know what that looks like, and a basic cosine. The other thing that it's going to talk about is how to translate the graphs, how to move them left or right. It's going to talk about the leading coefficient tests, like if you have polynomials, what a rational function is, and then it ends with composite functions and even and odd functions, which we talked yesterday about even and odd. So the even odd tests are the same exact tests for symmetry, checking f of negative x to see if it's the same or opposite. Okay, and what P3, we only go P1 to P3, I don't even know if there are other key sections in the chapter. But those are the only 3 sections that we do, just to kind of, some of the stuff's repeat from summer packet, but it's basically just all of the review algebra stuff that we need to know. So homework is to read through and finish the outline, and there are some problems from P3. And we'll do the activity tomorrow on algebra errors. Answer any leftover questions that you have before Thursday. Any questions? So tomorrow's kind of like a wrap-up day and go over homework, do the activity.